So we talked about the different solids that you need to be familiar with in the previous section. What we're going to do for these next couple is talk about the volume and surface area formulas for them. Starting with today, we'll look at prisms and cylinders, which are built similarly, right? They're basically just a stack of the same base shape up to a given height. And that's how we're going to calculate their volume. So we are introducing volume here. Volume is a three-dimensional measure of the space that a figure takes up. And you can think of volume as basically being, like if we look at this prism right here, if we take the base shape, so it's a rectangle or square, whatever it happens to be, if we take one of those, the volume is going to be that base area stacked h units high. So if you just kept stacking this base on top of itself, again, until you get to the level of this height, that is the calculation for the volume. It's capital B times capital H for any prism. Hey, whatever the shape happens to be. So if it's a triangle as the base, then you just stack these triangles on top of each other until you form whatever the height is for that triangular prism. Okay? And so capital B, capital H is your formula where B is the area of the base. And capital H is the height of the solid. Okay, and so the capital H is different than lowercase h. Same with the capital B represents something different than the lowercase b. So like in this, this prism that's indicated right here, your volume is going to be the area formula of the base, which is base times height, right? It's a rectangle, times the height of the solid. So notice this portion, the capital B portion, is going to change based on whatever the shape of your base is. Right, as far as the formulas that we're going to use or the types of solids, I've mentioned this before, but we are going to focus on what are called right solids. A right solid means that the top base and the bottom base are directly on top of each other. Okay, they're at a right angle to each other. This example here where your top base and your bottom base don't line up vertically is called an oblique prism. Oblique just means not right. Okay, so if you're talking about like angles, and you have three classifications of angles that we discussed, right? You have acute, right, and obtuse. So oblique would be obtuse and acute, the ones that are not right. Okay, so oblique prism just means it's the bases aren't stacked vertically. And so when you use these formulas, you're simply going to apply what you see. So if we look at this example to the right here, identify you're dealing with the prism. It has a rectangular base. So your volume formula is capital B, capital H, where base is a rectangle. So the area formula for that is base times height times capital H, which is the height of your solid. And so it's just a matter of plugging in the pieces. So if you use 14 as your base, 8 as this corresponding height of that rectangular base, and then capital H is the height of the whole solid, which is 5. That's going to give you your volume. And remember, you can type in the calculation itself. And so this is what I would recommend. Just enter this as your answer. And if you do that, then you get your answer, which in this case is 560. Notice the units here are provided. Volume is a three-dimensional measurement, so it's cubic units or inches cubed in this particular case. All right, so I want you to try this problem here on the bottom left. See if you can find the total volume of that trapezoidal prism. Again, oftentimes the problem will specifically tell you the shape of the base. But see if you can calculate its volume. And you do need to be familiar with your area formulas for the different polygons, right? So triangles, 1/2 base times height. Rectangles, base times height. Trapezoids, 1/2 the sum of the bases times the height. Regular polygons, 1/2 SAN or 1/2 AP. So those would be the main formulas that you'll likely see. So in this problem, your base is a trapezoid. So the volume has a formula of capital B, capital H for a prism. And if you replace capital B with the area formula of your trapezoid, which is 1/2 the sum of the bases, times the height of that trapezoid, all times the height of the solid. Again, this is why I will use capital H and capital B to represent different measurements. And now if you just plug in what you have, so one base is 19, the second base here is 11. Bless you. So 19 plus 11 is the sum of the bases. The height of our trapezoid is the perpendicular distance between the bases, which we see labeled right here as 12. And then the height of the solid is this measure, 21. So once again, these are calculated values, so you can just enter your answer as a calculation. And if you type in that and multiply through, oops. So if you calculate the sum of these, or the total product of these, you get your answer of 3780. Once again, the units are provided here for you. It's a volume, so it's cubic units. The units are, or in this case, actually, it's centimeters. So this should have been centimeters cubed, okay, for your solution here. All right, so I want you to try this last example on this slide. This is a little bit more challenging because it involves some other things that we talked about in the chapter on triangles. Okay, but see if you can find the total volume of that prism. One formula. Once we get the other volume formulas, you have to make sure you can distinguish which belongs to which. So the first thing is to realize you're dealing with the prism and you're being asked to calculate volume. So that's capital B, capital H. And then determine what is the shape of your base. Well, our bases are these right triangles here. So we can replace that with 1/2 base times height times capital H. And then start plugging in what you know. So the base of our triangle is 27. The height of our triangle is this measure. We don't know what that is. We know the hypotenuse is 45, and we know one of the legs is 27. So we can find this missing leg here, I'll call it H, by using one Pythagorean theorem. That's one possibility. So we know that H squared plus 27 squared is equal to 45 squared. If we subtract 27 squared from both sides and then extract the root, we could enter this as our H value. Okay, but there's another way that you can approach this. If you recognize, so one of the common triples that we looked at, remember, were 3, 4, 5 or 5, 12, 13 triangles. If you see that this fits the pattern of, this is 5 times 9, this is 3 times 9, so it's a 3 blank 5, it's a 3, 4, 5 common triple. So that means that this side H is going to be 4 times that same multiplier 9, which is 36. So the height of our triangle, or the other leg of that right triangle, is 36, which is what we would get if we did the calculation, right? So if we took the square root of 45 squared minus 27 squared, notice it's 36. We get the same thing either way. And then the height of our solid is 8, so that's this last number. And so here is your solution. Just enter the calculation itself and you're good. If you enter the calculated value, that's fine as well. And you get 3,888. As your solution. All right, questions on that, looking at prisms. So this volume formula also works for cylinders. Okay, and that should make sense, right? Because a cylinder also is a three-dimensional measurement of a single base shape stacked on top of itself to a level of H units high. The only difference is that in a prism, the base shape is a polygon. In a cylinder, it's a circle. Okay, so you're thinking of the same breakdown, capital B, capital H. But because the area formula of a circle is always the same thing, pi r squared, you can actually just memorize this as its own formula. And just like with the prism, you're taking one circle, and you take that area, and you're going to stack that until you've reached the height that you're looking for. So if you took this stack of circles to be h units high, that creates your cylinder. And again, that's the area of the base stacked h units up. Once again, you see here you have a right cylinder and an oblique cylinder. We'll focus on the right cylinders. And so that's the type of questions that you will likely see. All right, so try this first question here and see if you can answer that based on the formula that you see here. Again, it's in a similar fashion to the volume of a prism. So you recognize you have a cylinder. It's a stack of circles, so that means its volume is equal to base times height, where base is an area of a circle, pi r squared times h. And so it's just a matter of finding. Here's our radius, 4 squared times our height, which is given as 18. And once again, you can enter your answer just as that calculation. You can also enter it as the decimal equivalent. And so if we actually multiply that through, we get the solution to be 904.78. The units here, it's still volume, a three-dimensional measurement, so that's cubic units, which are centimeters in this example. All right. So let me talk through this next example again. You're going to see questions like this for each of the rotational solids. And that is, instead of being given the diagram, you're being described what figure is rotated about one of its edges or sides to create the solid. And so here it says that you're taking a rectangle with a base of 16 and a height of 22. And you're rotating this about its height. So you're told that the height was 22. So if you rotate this all the way back, you get that cylinder, right? And when you look at this cylinder, you see that the total height was the 22, and 16 is the radius of that cylinder. So when you plug this into the volume formula, capital B, capital H, where the area formula is pi r squared, you can substitute in your radius of 16 and your height of 22. So that is your calculation, which is what I would enter more than likely. If you're doing the calculation itself, you can type that in. Notice in this case, because of pi, you're going to have decimals. And so the decimal equivalent would be 17,693. It says to round to the nearest hundredth, which is 2 decimal places, so we'll round to 4.45. Once again, this is a volume, so it's cubic units. There's nothing specifically labeled here in the answer like the other ones were. So this is cubic centimeters. You don't need to enter that unless there's a drop down where it asks you to identify it, but that would be the proper units for that. All right. So half of the questions that you're going to see will be volume of cylinders and prisms. And the other half are going to be surface areas of those same two shapes. And when you think about the surface area, sometimes it's easiest to think about the net that is created by these prisms and cylinders. Because if we think of this, the net here formed for this triangular prism, what you're going to see is your base has 3 sides, so that means there's going to be sort of 3 sections of that flat lateral surface that's rectangles. And then there'll be another base opposite this that's the same. So what you can see with your total surface area is it winds up being just the sum of all of the areas, right? So if in doubt, if you don't remember how to calculate it, just find the area of each individual polygon in the figure and then add them together. But if you think about what the net looks like, you have 2 bases, And then to that, you're going to add these rectangular regions. Well, this rectangle has a total base and a height. Well, the height is the height of that solid. And the total sum of these sides here that form the base of the rectangle also form the perimeter of this base shape. So it's the perimeter of your base times the height. Okay, so again, in this is the area of your base. Whatever polygon it happens to be, it'll be that calculation. P is the perimeter of the base. So just combine or add up all of those sides, and then H again is the height of the solid. Okay, and that works for everything. So if you have a prism with 4 sides to its base, right? Here would be your 2 rectangular bases, and then this would be the perimeter of that base, and this would be the height of your solid. Even if you had a, let's say 5 sides, where you have a pentagon off here, you have 2 of the same bases plus your 5 rectangular lateral faces combined to form 1 rectangle that's the length of your perimeter plus the height of your solid. So this surface area formula works for all prisms. Okay, so really quickly, see if you can calculate the total surface area of this box, this rectangular prism. Okay, if you're familiar with the formula, you can just apply it. 2 times B plus P times H, where the base is a rectangle, so base times height. The perimeter is 2 bases and 2 heights, so 2B plus 2H, all times the height of that solid. And so if we're just looking to put this into a formula first, this is what our formula looks like. And then if we plug in the numbers for that, 2 times the product of my base times height, so 10 times 5, plus twice the base, so 2 times 10, plus 2 times 5, all times the height of the solid, which is 4. So once again, if I'm doing this, I'm just entering my calculation as my solution. But you can also do the calculation separately. And if you do, you get your answer here. The total surface area for this would be 220. Now, area is a 2-dimensional measurement, so it's square units, which is why you see it labeled there. Okay, it's 2 dimensions for an area. All right, so try this last question here on this slide. It's a similar one to what we saw on the couple slides ago. And can you figure out the triangle involved and calculate the total surface area? Okay, so I'm going to show this one with the net, and you don't need to draw out the net to do it, but I'm just going to show you that you can. And if this is the case, you have your right triangle here. And so we have a side of 15, a side of 9. If you want, you can use Pythagorean theorem again for that. You get a squared plus 9 squared equals 15 squared. Subtract 9 squared from both sides and extract your root. That will give you your a value. You could also, if you recognize, here 9 and 15 have a common factor of 3. This is 3 times 5 and 3 times 3. So that's, again, a 3, 4, 5 common triple with a multiplier of 3, giving you a side of 12. So you know that this piece right here is 12. Okay, and then when you match these, this length would be 9, this length here would match to the 15, and so that gives you all the dimensions you need for this figure. So if we're calculating the total surface area is going to be twice the base plus the perimeter of the base times the height. The bases are triangles, so 1/2 base times height plus The perimeter of a triangle is just the sum of all three sides, so A plus B plus C, all times H, the height. Oops, sorry, the height is capital H here of the solid. And so if we just plug in what we have, the 2's cancel. The base of this, if we use 9 as the base, we get 9 times the corresponding height as this measure, which we found to be 12, plus the sum of the bases, so 9 plus 12 plus 15, the sum of all those bases, times the height of the solid, which was 11. So this would be your calculation. And if you perform the calculation and just type in what you have, you get 504. Once again, the units for this are square units. The specific units are meters, and so you would get 504 square meters for that surface area. All right, the surface area for a cylinder is really no different. It's built from, it's using the exact same formula. It's also built from the net if you need to refer to that. But if we took twice the bases plus the perimeter times the height, it's really the same thing, because if you look at the net on a cylinder, and you have a circle on each side, so there's your 2 B's. You have this rectangle that's formed. The rectangle has a height that's capital H, the height of the cylinder, and this length here of that rectangular lateral face just wraps around the circle. It's the perimeter of this circle, but the perimeter of a circle is called circumference. Okay, and now because our base formula is a circle, 2 pi r squared, because we know r is going to be involved in this, I'm only going to use the circumference part that has the r, which is 2 pi r h. You could have done d pi as well, right? But you do need the radius anyway. So d pi versus 2r pi, I'm just going to use this form. Okay, so here is the formula for the surface area of a cylinder, but really it's no different than the formula for a prism. If you have 2 congruent parallel bases, and this is, and it's a prism, this is what your, or prism or cylinder, this is what your formula looks like. Okay, so again, if we just take this first example, I'll talk through, and we use the, sometimes again, it's helpful to sketch what you have. You have surface area is 2 bases plus the perimeter times h, where the bases are circles. The perimeter is a circumference. And so there's your calculation. 2 times pi times our radius, which we see is 9 squared, plus 2 pi times 9 times the h value, the height of that whole solid is 21. And so this calculation would give me my answer. And if I was doing the full calculation itself, I would get 1,696. .46, we round it to 2 decimal places. The units here are square centimeters. It's a 2-dimensional measurement. Area is, surface area is just an area. And so those would be your 2 possible solutions. All right, so I talked through this rotational problem last time, so try this one here on your own. And can you calculate what would be the surface area if you're given a rectangle that's rotated about one of its sides? And if you do the calculation, you get your answer, which for this would be 3694.51. The units here are millimeters squared. Surface area is a 2-dimensional measurement. All right, so that's the majority of what you're going to be working with. Okay. The last type of question that you're going to see has to do with the ratios. We've talked about anytime you have similar figures, the ratio of parts is some ratio, m to n. The ratio of any areas or two-dimensional measurements are going to be the ratio m to n for each dimension being measured. So area is a two-dimensional measurement, so you square that. And that leads to the natural conclusion that for volumes, which is a three-dimensional measurement, if you have similar figures, then the ratio of their volumes is going to be that same ratio m to n for each of the three dimensions. And so you're going to need to cube that. And so this is the relationship that you're looking at for these. All right, so there's a couple different types of questions that you might be asked here. And so one is if you're being told that these are similar solids here, and you can see just from looking at these that they have a ratio of given parts, right? 2 to 11. The ratio of their parts are one-dimensional. That means if you're trying to identify what is the volume of that larger cylinder, moving from ratio of parts to volumes, we're going to take this ratio 2 to 11 for each of the dimensions and cube it. Okay, so you get 2 cubed, which is 8, to 11 cubed, which is a little less common. You probably wouldn't know this offhand, but you get 1331. So these are the ratio of our volumes, which means that you have a conversion factor of 1 over the other. 8 over 1331 or 1331 over 8. It all depends, are you making something smaller or bigger? Well, here we're going from 81 pi to a larger figure, right? So which of these ratios would we need to make it that number larger? So 1331 over 8, if you multiplied that, that's going to give you your new volume. Okay, so if you were calculating the actual decimal equivalent here, 1331 over 8 multiplied by that ratio, and you would get your answer, which is 42,337.28. Here the units are inches, volume is a cubic measurement, and so those would be your two possible answers. Again, I would recommend just put the calculation in. All right, so let's talk through this last one, though. The last one is the one that's probably the most challenging, okay, and that is instead of starting with the ratio of the parts, you're instead given the ratio of their volumes. And so notice that we're now starting down here, not up here. So if we see that the ratio of their volumes is 73 to 227, in order to work backwards, if you know that this corresponding measure is 12 and we want to find the smaller one, so we're going to take 12 times some conversion factor that's moving, or that's relating the ratio of parts, we need to move backwards. Well, how would we move backwards from m cubed to just m? What would we have to do to both sides, or to that expression to get from m cubed to m? You have to take the reciprocal power. So you can either think of it as taking it to the power of 1 over 3, or you can think of that in terms of the roots, the nth root, and take the cube root of 3, or sorry, the cube root of m cubed. So the way that we can move from the volumes to the parts is we take the cube root of each of these, okay, and that would be your answer. Okay, there is a drop down on the equation editor with the cube roots. So again, what you would get right here is the cube root of 73 over the cube root of 227, or the cube root of 227 over the cube root of 73. Again, this one makes it smaller, this one makes it larger. Are we going from big to small or small to big? From big to small, so we need the one that gives you a number less than 1, which is this first one. So we'll multiply this by the cube root of 73 all over the cube root of 227. And again, the cube root can also be written as a rational power 1 over 3, where this number right here is it's called an index of your radical. Okay. But both of these have those calculations. So if I want the cube root, the drop down is going to look somewhat similar to this. Here it looks like you maybe need to go to some added roots here. Actually, yeah, so it looks like that doesn't have the root. Let me see if it's going to be in the function command. All right, so if you find in the function command here, you can find the nth root. And so if you're calculating that, you type the index of 3 over 73, and then put that all over. Again, go back into the functions, scroll down to number theory, click the cube root, or the nth root, and change that index to a 3 over 227, and that gives you your answer here for this. Oops, this should be a 73 here. Okay, and so you get 8.22. And so either of these is going to be fine. You have your calculated form and you have the calculation itself.